video series on this battery saga. Then we've come to an end where we've built both the battery packs now. So there was 133 cells in each pack. They're a pack rather than modules, or where people generally do it. And the reason I did that was because it makes the pack smaller and less higher current for the vehicle. There's a lot of hoo-ha about which one you would go for. So let's just go over some quick figures here, because if you don't want to watch the rest of this, it's just not worth it making used laptop batteries into battery packs. And the reason for it is this: if I bought some battery packs and I got 10 of them, I pay between £20 and £30. That's an eBay price currently. Although someone was offering 60 for £55. Whichever way you look at it, and we do the maths on it, it comes up as it costs you £266, and you get about 1.2 kilowatt hour battery. Now, if I bought them new, I'd have a higher power slightly, but it would cost me £532. So that's, you know, almost double the cost. And I'd get about 1.67 kilowatts, so I'd get about 500 watt hours more. But on the flip side of that, if I went to LFP or lithium lipo 4, then I'd get about 169 watt hours, which is a 438 watt hour difference, and I would pay £256. So I'd actually save money by using new LFP cells. I'd have a lot less of them, making it easier and cheaper to put it all together. So it isn't really worth bothering with used laptop batteries because they're a mixed set of batteries. The output current of the cells is usually around about 4, although we did find a couple that were around 2 amps, so that's their maximum continuous discharge. With the new cells, they were all higher capacity and they had a higher discharge rate of 10 amps, so you can do it that way and get yourself a decent battery, but you're still paying double the money effectively, and you're not going to get a huge amount of performance bonus overpaying half that price and using AFP cells. So yeah, so we built the batteries, we put an active balancer on one, so this is the next follow-on video. We put an active balancer on one, we put a BMS on the other with balancing on there, and the actual, it's odd because they've been left now for quite a while, and what we've got is the active balancer battery is performing perfectly, and the BMS one is ever so slightly off, although I did notice on the BMS that the battery voltage was showing slightly different on some of the cells than what they actually were, which is a bit of an oddball. I'll get back onto the supplier and see what they have to say about it, and then we can go from there. But yeah, it's just not worth it doing it. It's a lot of time. It took over 400 hours to do it. We used a multi-cell, full cell battery capacity tester, which was discharging and charging at 1 amp, which is probably more of a regular use than rather capacity matching on the 500 milliamp testers. I had to build a bigger charger so I could put at least 16 cells on there, and it's just really the time. Nickel obviously is toxic when you're working with it as well, and I got a nice cough from that. What else was there? Nothing. It's just not worth it. It's not even worth bothering really doing the videos for it, because they're not 100% safe. There is safer alternatives, shall I say. That's probably a better way of explaining it. It's safer alternatives. There's a lot less messing around with the bigger cells, and so yeah, it's just not, and it's cheaper. So why would you bother, you know, spending 400 hours taking apart laptop batteries, cutting yourself, having shrapnels and the explosion risk of the cells, over doing it. So yeah, we've built them. I'll just tag on the videos that I shot whilst I was doing them, and you can look through those. They are commentated, I think, all the way through. But there's a couple of videos where we're showing different things all the way through, and if there is anything, I'll just write a text on the bottom. Okay, thank you for watching.
So I don't think a lot of people tell you that
You're doing charge cycles that take 3 hours. You've got to charge them up. You know, you need multiple chargers. This is our DIY power, which is quite common where people use laptop batteries. We've got 400 or so of them, so we're going through just building it up and checking and marking and capacity checking all of the batteries, which isn't fun at all. So now I'm on the big batteries. These take around about 5 hours to do. So on this charger and tester, we're letting them run a cycle so we can get the capacities off them. This will charge them up, discharge them, and then recharge them. I pull them off just to save time, put them in this charger. That's 726 amps. There we go. In an hour and 33 minutes. So this has been running for an hour 33, that's been running for an hour and 22. So I've got about another 100 or so of these to do. So that's well, it takes about 10 hours to do 2 sets, so about a day to do them. So I'm just leaving them on auto, doing themselves, sorting themselves out, and we're almost finished. So if you look at the voltage on the milliamp hours, and then I go over to this old Samsung battery here, it's a 2.8. You can see it's at the same sort of voltage, 137, 138 milliamps. So you kind of, that one's 375 and 544. This one's in its charge cycle. This is the Sony from the STIHL battery. So we sleeved this one because it was a bit messy. So as you can see, you can tell generally as you're going through of what sort of power you're going to get from a battery. Now this one's going to be way low, so this one's an old one that's been hovering around and the voltage had dropped on them. They're a bit of an old set that I keep for little small projects. One of the hardest decisions in making this is which configuration to have the batteries. Do you have them in big cells, parallel packs, or series packs? And this is one of the big things that I had an issue with, is I can do it like this, which seems like everyone else is doing it. There are 24 cells per pack, but yeah, it was a real challenge of, do you make a normal battery pack as in a single pack using the blocks here, or do you put it together as little single units and then BMS across the whole lot? The reason for it is the power that comes out of these individually, regardless of which way you've got the pack configured, can make a difference to the size of the pack and your layout. Because if you wanted 48 amps out, then you would put it together like this, and that'd give you the 48 amp quite easily out of them, although they're 5 amp cells, most of these. But of course then you need a lot more cells to make your packs up. So I've decided to do it this way. I'm short a couple of cells, but I've got plenty more anyway, of the high-end cells there to go in. So I got this far through a kilowatt pack and then realised I typoed because I'm tired and I hadn't gone to sleep for days properly after sorting these things out. Sorry about the gaudy table mat here. So the one thing that always bugs me about, yeah, we can touch that on there, is that the head size here when you're soldering on your strips, or welding on the strips, is that it's very small and difficult to see. Look at the size of this one here. So you have to be really careful of how you line up your strip to make sure that it fits well on there all the way through, and then welding them, make sure they're level, because if you go off, sometimes what happens is when you weld on one side, it will try to twist it ever so slightly as the metal expands, and by the time you're at the other end it could be way off. So what we've done is it's supposed to be like these, right? So we've done this side, so we've gone negative, positive, negative, positive, negative, positive, and on the other side obviously we're going to be connecting across here and across here and then at the top up here to finish off this. Whilst this is like this, there's no danger of pack voltage problems or anything like that. However, as soon as you start putting the other side on, then you do create the circuit there, and you'll get inrush currents and everything else like that. This pack has been a bit of a pain in the neck, and I've had to go back through and resolder some of these, and I'm going to put solder joints in some of them because they just weren't taking. So it was a bit of a problem getting this to actually solder on, whereas the other pack had no problems at all with the spot welding. So a bit of tape on here just so I know never to join those two together, because obviously that's a direct short. So we go these two, and these two, and then that's the pack all welded together, all done together. And these things are a bit of a pain in the neck. So these ones here, it won't contact down, so I'll have to get the little grinder out to grind those off and just go through the pack. But however, last night when I was doing this, before we soldered one in, there was one battery actually ran the wrong way in here, and I didn't actually notice because it's obviously there's 133 batteries to check. Checking the voltage, and the voltage actually seems very high, but this because there's quite a lot of 4.3 volt cells in this. So if we go over to the multimeter, you can see that, can't you? So if I go peel this off, so if we go here, this is difficult trying to do this while I was trying to video it. So if we go on to the where can we get, there we go. So as you can see, my voltage is 4.32 on the cell, so apparently they're well over voltage, which is really concerning. I need to check this is calibrated, because obviously it's been really hot recently and there may be a problem. We're putting the pack together. What we're doing is on the other side, so you've got on the bottom half, these are two soldered, these are two soldered, these are two soldered, this isn't soldered, this will be coming across the top. So what I've done is put a bit of tape on there, and this just lets me know that I want to get it along here. Now if you notice down, these are 5/4 cell pack spacers, and then down here we've got one of them with two blocks of single cell cases, and they're ever so slightly different, so you have to smack them a couple of times trying to get them to level up. So when you come to solder across these, it can be quite tight. But one of my big issues is where you put on this, and by the time it gets down the other end, it can be off. And if you look, if I started soldering down here, or spot welding down here, this tiny little head here and here, they're quite difficult to get on, and it's like a danger zone thing, because you don't want to miss where you're trying to actually solder to. I mean, these ones are fine because they cover the whole area, so it's very easy to get them on. You just solder each side. But I did have lots of problems with this pack being able to solder. A lot of them, they were literally popping back off. So I have to go back, and this will be double checked to solder any of the joints that are on there. So you've got this. So what I do is put a bit of flux inside the gap there, and I've got my soldering iron fits directly across this, and it's just a matter of just dabbing it on there quickly and getting them soldered. But yeah, there's been this hasn't been a great pack, so there's over 1.2 kilowatts I think here. So they are, you know, dangerous enough to be doing, but yeah, that's about it, I suppose. This pack will be put together with a BMS, but our pack voltages are all good. Let's see if we can get on the end. There's an end there. So we're sitting around, there's my multimeter there, you can see, although I can't see video and do this all at the same time. There we go, 4.17, and then the other one's 4.17, 1.18. So it works out that if you're putting these together, you want to check all your cells. I had one cell that I must have mischarging, and what had happened is that it was sitting low, and it was a 0.7 0.07 of a volt, it's something like 1 amp or something like that. So what you want to do is check all your pack voltages, even if, because obviously it takes a while if you're charging them, just to make sure that they're all up to spec, so that you are not going to get a big inrush of current across the pack while you're building it and when you start using it. Because obviously what people probably don't notice is that the inner cells will balance themselves. It's the outer cells which don't make a circuit, so they can't effectively balance themselves and level out.